So this is Stoshi Caleb from Special Maths Academy, and in this video we'll be solving the problem 11 from the NMC first round. That's for the senior mathematics. So here we are given two positive real numbers x and y, and we are told that x squared plus y squared plus x plus y squared all over x squared y plus xy squared attains its minimum possible values. I have to find out which of the options is true. So let's start with what we are given, right? We are given x squared y squared plus x plus y squared over x squared y plus xy squared. Let's try to simplify this a little bit. So this is equal to x squared y squared plus x plus y squared, of course, all over. Now we'll bring out xy. So this will be xy times x plus y. Right, so this is basically the same as this xy squared all squared plus x plus y squared over xy times x plus y. So I'm sure you guys have noticed that what we have is of this form a squared plus b squared over ab, right? And we are told this it attains its minimum possible value. So we can actually decide to, instead of working with x, y, and x plus y, we can actually decide to work with a and b. So to do this, let's set xy is equal to a, and x plus y is equal to b. They will now have the expression a squared over b squared all over ab attains its minimum possible value. So now this is where, how do we deal with this? This is where the inequality comes in. And to handle this, you're going to use AMGM. Right, so AMGM tells us that a squared plus b squared is greater than or equal to 2ab. Right, so this implies that a squared plus b squared over ab is greater than or equal to 2. So now this implies that the minimum possible value that they are talking about here is 2. Right? But that is not our concern. Our concern is when that minimum possible value is achieved. And we can get that. Why? Because AMGM also tells us that this minimum possible value is achieved at A is equal to B. Right? So from this, we have A is equal to B. And that's good, right? Because this implies that xy is equal to x plus y. And from this, we can derive whatever options there are, whatever options that's given to us here. So let's work with this a little. From this, if we try to express y as a function of s, let me say, we get xy minus x equal to x. So this implies that, xy minus y is equal to x. So this implies that y times x minus 1 is equal to x, which implies that y is equal to x over x minus 1. So from this, we now know that whatever or whichever xy that's in this form, x over x minus 1, is going to attain the minimum possible value, which is 2. right? This is what we have for now. But what I actually asked to show is which one of these x plus y is equal to 4, x is equal to y, x plus y is greater than or equal to 4, or x plus y is less than or equal to 4, or xy is equal to 4. We're actually trying to find which of these is true. So all we need to do is to test or prove for x and x over x minus 1, which of these options is going to be true. So now we are going to prove, or we have a claim that x plus x over x minus 1 is greater than or equal to 4. Right, so by our claim, it means that option C is the correct answer. So we have to prove this first. And to do this, let's try to simplify x plus x over x minus 1 first. So this equals to x times x minus 1 plus x over x minus 1, which is equal to x squared minus x plus x over x minus 1, which is equal to x squared over x minus 1. Now I'm trying to show that this is greater than or equal to 4, right? So maybe we can work backwards a little, right? So let me separate this part. Let's work backwards a little. I'm trying to show that x squared over x minus 1 is greater than or equal to 4. So now this is true if and only if x squared is greater than or equal to 4 times x minus 1, which is true if and only if x squared minus 4x plus 4 is greater than or equal to 0. Now this is true, right? Because this is equal to x minus 2 squared, and this solves the problem, right? This was working backwards to tell us maybe what we need or how we can solve the problem. So for the actual solution or the actual proof of this claim, we start from the back, which is x minus 2 is a square, so it's greater than or equal to 0. And that implies that x squared minus 4x plus 4 greater than or equal to 0, which implies that x squared is greater than or equal to 4x minus 4, which implies that x squared is greater than or equal to 4 times x minus 1, which implies that x squared over x minus 1 is greater than or equal to 4. Now, this has proved our claim, right? So this has proved our claim, right? Because our claim says x plus x over x minus 1 greater than or equal to 4, right? So this has proved our claim. So now by our claim, remember that y is equal to x. Remember that y is equal to x over x minus 1. So this implies that x plus y is greater than or equal to 4. So from our claim, C, option C is the correct answer. And then we are done with this problem.